So let's talk for a minute about how to eliminate the last and most annoying manual step in thermal desorption GCMS analysis, which is the spiking and drying of thermal desorption tubes prior to analysis. This is normally done with an accessory called internal standard dry purge, and let's talk about this in detail. So how do we add internal standards onto thermal desorption tubes? As an example of this, let's consider air analysis, just regular outdoor air analysis. If you're analyzing outdoor air, there'll be a number of things in the air. Anything from very volatile compounds to volatile compounds to semi-volatile organic compounds. Also, because it's outdoor air, there's going to be water in it. If you are north and close to the North Pole, not very much. And if you are somewhere in the Caribbean, it'll be a lot. But one way or the other, there'll be a lot of water there to deal with too. In thermal desorption, we can sample all these things easily onto a tube, but usually just by pulling them onto the tube with an air pump. So all of these things can be easily sampled onto a thermal desorption tube. But before we analyze these compounds that are on the tube, you need to add a fifth component, which is your internal standard. This is normally done by using a purge gas like nitrogen to push the internal standard onto the tube, and then it's loaded on. Internal standards are very important. Classically, in gas chromatography, internal standards are used to correct for injection variation. However, they can also be used to monitor instrument performance and can be used to identify instrument problems. For example, loss of response in a mass spec detector. So this is a great way to improve the quality analysis if you can add an internal standard on. So now we have our internal standard on there. Is it ready for analysis? Unfortunately, the answer is no, because GCs don't like water. Remember that example I said about the Caribbean? Yeah, if there's a lot of water on there, we need to deal with this water somehow. Well, there's some good news. The same gas that you use to purge the internal standard gas onto the tube, if left on, can be used as a drying gas to purge water off of the tube. It's all about timing. If you don't leave it on too long, you'll drive the water off, but you won't lose any of the analytes this way. So consequently, we're going to be able to use this purging gas as a drying gas. This is very efficient. There's no additional parts, no extra tanks of gas, no extra regulators. The drying gas flows in a sampling direction. That's very important because if it goes in the other direction, it might blow things out. So no, it's always in the direction of sampling, which is the correct way to do internal standard addition. This prevents the loss of analytes during drying and keeps our sample integrity where it should be. So now the TD tube is ready for analysis. So this is how internal standards are added and how water is removed from tubes. Unfortunately, that's usually done manually, as I can tell you from my own personal experience, and it's very annoying to have to do this tube to tube yourself. Wouldn't it be great if there's some way of automating this? And the good news is, at GERSTEL, we've developed a way to do this for you. We have two different accessories for this, ISDP and ISDP Plus. No matter what you're doing, we have the right internal standard and drying solution for you. Let's talk about ISDP first. ISDP works by taking a fixed volume of gas through a fixed volume loop and purging that onto the tube. This is typically either 100 microliters or a milliliter worth of gas. These tubes are automatically placed into the ISDP and automatically loaded with this internal standard gas. This is done using full electronic flow control, no touching needle valves. Everything on it is controlled precisely electronically in terms of pressure and flow regulation. Alternately, with the ISDP Plus, we're going to solve the same problem in a slightly different way. Now we're going to load gas or liquid standards with ISDP Plus. If you notice in the picture, there's actually two little injectors there. So now instead of using a fixed volume loop, we're going to use variable loading volume by using the syringe. If it's a gas, it'll be a gas-tight syringe, typically 1 milliliter worth of gas. If it's a liquid, it's probably a 10 microliter syringe, typically 1 microliter gets injected onto the tube. This is how you load internal standards. Alternately, using the GERSTEL Maestro software, you can actually set up and build a full calibration curve this way. If you can spike 1 microliter of internal standard onto a tube, you can spike variable volumes of standards onto the tube, onto several tubes, and build a calibration curve. As with the ISDP, there's very precise pressure and flow regulation, computer controlled, and as with the ISDP, efficient drying is carried out in the sampling direction. So no matter what you have to do, whether you want to spike just gases or spike liquids, GERSTEL has a solution for you to both make your analysis more reliable and to get the water off the tube, to eliminate the last, most annoying step in thermal desorption analysis. Keep an eye out for other FlashTalk videos and stay curious.